not that bad an idea. Oracle 11G Release 2 is available. The fact that it won't install on my machine probably won't stop you from installing it on yours. This is a pretty big package. It comes with lots of options. Try to pick a simple one. The simplest one is going to be fine. You know, so try to tunnel down till the install is easy. The default user on this is Scott/Tiger, username, password. All right, I might have mentioned this last time. I don't remember. The theory on this is that Scott was an early founder of the company, and he had a pet named Tiger, and so it's sort of this dates back to the first month of the company, probably. All right. You will find that it's profitable to log on under the following database administrator name: sys, sysman, sysdba, stuff like that. And when you install this, they will ask you to pick a password for all of these default, there from the beginning, administration accounts. So it's part of the installation process. You pick a password. Probably on the 11G, they will ask you if you want to change the default instance name. The default instance name is ORCL. Okay? So, you know, that's one thing you could do, is to download that to your machine. That way you'll be able to run things this week without emailing me. Now, some of you have already done that. Okay. The plan B, which is a simpler footprint and an easier install, is Oracle 11G XE, which is short for Express Edition. This then becomes the instance name. Okay. The default user is no longer Scott Tiger. The default user is HR, and the usual password is typically to just duplicate it. That's what I always do. So I use HR. Now, to log in the first time, you're going to have to log in as one of the system roles. So, right. So you could do, you know, SQL plus sysman password. In Oracle, you use a standard slash to separate username from password. Okay? Once you do that, you can look up online, you know, how do you log in? And another suggestion is something like, in double quotes, /sysdba. I'm not going to try to predict exactly what will work. You should be able to fight your way through with Google. Okay? But here's the trick. With either of these, you could find that the default user account is not working. And so I'm going to tell you how to fix that. Once you log in as one of the system people, you are then in control of accounts like HR. And the following commands will do you a world of good. Alter user, 2 words, HR, account unlock. Because by default, it's usually locked when you first download it. And locked means you can't get into it. Now, if on our accounts, you make a lot of unsuccessful login attempts or otherwise piss Oracle off, you might find that your account is locked, ST06 or whoever you are. You might find that your account is locked. When that happens, you're not going to be able to unlock it. You don't have enough clout. So then you have to email me and say, my account is locked, and I will run this on ST06 from my Oracle account, which is a system manager account. Okay? So if you ever find that it says your account is locked, you deal with that through me. Okay. The other thing that you might have to do with HR is this. Alter user HR identified by HR. And if you do that, then the conventional HR will now be working, and that's really easy to remember. So why screw with something more complicated? That is like Scott Pike. That is the new default on the Express Edition. All right, the Express Edition will do PLSQL, it will connect to Java, it'll do everything we need to do for the class, yes?
You misspelled identify. Is it supposed to be that way, or?
Oh, I'm missing a D.
Okay.
There it is. Identified by HR. All right. I have an announcement about the grading. Some of you have changed your MASC password, and the grader needs to get into your MASC account and take a look at those two files. Okay. If the grader needs to do that, the grader agrees with me, she suggested, and it's what I've been doing on the weekend, the following device. She will set your password to the original one on the sign-up sheet. So if you changed your password and can't get in, try the original password that was on the sign-up sheet. And then you can probably get in. If that doesn't work, then you email me and I can fix it. Okay? But in the meantime, as a courtesy, leave your Unix password alone until you guys have a chance to, give you full credit on your wonderful assignment. Okay. Yay. All right, anyone need to add to the pile? Yes, a couple of people. This is going to be a going once, going twice. If you don't get it to these guys on time, we might not grade it until Christmas. Okay. All right, going once, going twice. Thank you very much. All righty. Yeah, it should be pretty quiet out there now that we're gathered. I'll leave the door open. So another adjustment that I thought I would make tonight is, since I don't have a connection to Oracle either, I'm as helpless as you are, and right, I can't wave a magic wand over the computer in there and put Oracle on it. Okay, so what I'm going to do is slightly earlier than I planned, start talking about some of the database theory stuff, which doesn't require a connection. So we'll start doing that for the first block of time here. And it's the part of the class that, you know, I tend to refer to as buzzwords. And, yeah, I don't like it much, but you're supposed to know them. So, off we go, and we'll do some of that. All right. The whiteboards could be wider considering what we're trying to do, given, you know, the size of the room. Well, let's do the following nomenclature. This ends with a joke or a punchline or something, although that wasn't the intention. GL stands for Generation Language. Okay? Now this is amusing. The idea is to look at different generations of language in the evolution of software from, I don't know, 1958 or something. Okay. So first generation language is defined in the database books as machine code. Okay? Now I remember those days. You actually sat at a console connected directly to the computer and you typed binary. Yeah. All right. Second generation language is assembler. They had that in 1960. Third generation language, higher level languages, be they imperative or OOP. You could call them HHLs if you want. And then, of course, fourth generation language is RDBMSs. Now, obviously, you can tell which industry invented this hierarchy. But anyway, the terms are pretty well known, so I throw them out. It's really ultimately pretty dumb. Okay. Now we want to go on to another list. This is a list of two. DA and DBA. All right, I'll get to those in a second. First, well, no, I guess we'll do them now. DBA is Database Administrator. I could scribble that over here. Database Administrator, that's DBA. DA could be District Attorney, but in this class it's Data Administrator. And this is actually kind of a useful distinction because of the different positions occupied by the people that do these two things. The data administrator is typically corporate rather than technical. Data administrator typically has an MBA, and he's high up in the executive hierarchy, high enough up so that he can decide which database vendor to use, SQL Server, Postgres, Oracle, whatever. He's high enough up so that he can decide what hardware to buy to support the database efforts. And the important thing he does is he decides what to put in the databases and what kind of authorization to allow for the stuff that's put in the databases. Which stuff is, considered to be, top secret, not so secret, Hillary secret. Okay. So that's the data administrator, and think of him as an MBA. And then the database administrator, this guy is a technical guru. That's how I describe him. He's the guy that actually knows the stuff that you will know at the end of 6 weeks and a whole lot more. All right. To be a certified DBA for Oracle, you pass something like 6 certification exams. And if you want to keep your certification, then, every so many years, you pass an upgrade exam. You don't have to take all 6 of them. It used to be these were like Java certification exams. You paid $150 and some other company administered the exam and you took the exam, and if you passed, you got some sort of a certification, some sort of a certificate, right? Then Oracle decided, no, we can make more money than that. So now, in order to be eligible to take one of their certification exams, they want you to pay to take one of their certification training classes, last I looked. That's not kind at all. Okay. So anyway, all right. No company is perfect, but that's sort of, I thought that was a sort of a low blow. All right, so now that we've talked about the difference between the BA and the DBA, we're going to talk about in greater detail some of the things that database people do before that gets down to database application programmers, which is what you're supposed to be able to do after we get done. All right? You can be a database application programmer, and there are certifications for that. Typically, there's a certificate for SQL, and either it's the same exam or there's a separate exam for PLSQL, and then they often have you also, just to prove how worthy you are, take the first Java certification exam. And if you do that, then they know that you can do JDBC so that your Java can talk to Oracle. All right? So, so the moral is there are many different certifications over at Oracle, and you take different exams for different titles. Java has like, 6, 7, 8 different certification exams. They've got a whole bundle. I once taught a Java certification prep class, and so I took the first one. I figured I should pass it before I taught people how to pass it. That was my only motivation for doing it. All right. Let's see. All right, we're going to continue with lists. Yeah, I can write on this. It's actually part of the wall. Database layers. 1, internal. 2, conceptual. Sometimes called logical. 3, external. You can see it coming. All right, so we want to discuss what these words mean with regard to database layers. You have a database table, and the question is, how do you store that physically? And you can store it in different ways to try to give people quick access to the information in the table. And that's actually controllable. Nothing we're going to cover. So you could set it up so that it was just a linear file. You could set it up as a balanced tree. Right, whatever you felt like doing in order to get faster access, and it might depend on the kind of table it was, or it might depend on how heavy the usage was. So who makes that kind of decision about the internal representation? So how is the data really stored? So are you gonna, access it, is it gonna be an AVL tree or, right? Are you gonna use, hash maps? Whatever. So it could be a hash table. And this is DBA stuff. Okay? Because he's the technical guy. So he's the guy who's supposed to make all those decisions. The application programmers need not apply. That's kind of his domain. Yes, sir.
Would be the programmers. So say you are trying to search for a string, and because it's indexes are hard or whatever, you
Yeah.
create another table based on like a hash of that string.
There are things the application programmer can do to speed access to certain kinds of queries, and we will cover that. But this is, how is it really stored on a hard disk? And application programmers don't worry about how things are stored on hard disk.
You mean like GUI, like the manager is what programmers deal with, and DBA deals with.
What we're going to learn about is you can create something called an index. And how the index is implemented is actually up to the DBA. He can probably control that. But the idea of an index is you say, column 17 out of my 33 columns is very often searched. So let's store column 17, as a hash table, so that with pointers to where the data really is, so that I can get at the stuff really fast. So we're going to learn how to do that. Okay. But this is talking about how the entire table is stored. Okay. Conceptual or logical design is, and I think we're going to start talking about that a little. ER design, and then this is conceptual, and then it goes to logical. And logical is RDBMS tables, the actual bloody tables. Okay? So this is this is the stuff that we're going to learn about a lot, is how to deal with RDBMS tables. This can be done by the DBA. This translation can be done by the DBA. It could be done by application programmers. We're going to learn something about how to do it. Okay. So anyway, conceptual or logical, and I find it easier to distinguish between the two and claim that logical is the actual database table. External is a special thing. I'm just going to write views. Okay. Here's the deal. You've got a table with 100,000 rows and 50 columns, and some of the columns are social security number and red ID, and some of them are salary, and some of them are what building do you work in. And you don't want to give everybody in the corporation access to every column. So what you do is create a view, and the view is a kind of a snapshot with blinders of the table that allows you to see certain columns typically, but not all the columns. Okay? So a view is a perspective of a table that allows you to see the part of it that's relative to your job description. All right? And it's actually a kind of object you can create, so we'll learn how to create views. But that's external. That's somebody who's, not a DBA, not truly on the inside, doesn't need to know everything. So this is a view or a snapshot of part of the table. that's available, vaguely speaking, from the outside, hence the word external. All right? Okay. So, okay, so this is, this side is DA. And this side is DBA. All right, and it's a good way to distinguish between our two friends, DA and DBA. The decision as to what the tables are going to look like, what fields they're going to have, what we're going to use for a unique ID, how many tables we're going to have, which tables are interlinked to other tables and how. Those are design decisions, and that's going to be done primarily by the data administrator, but probably with a DBA in the room. Okay? So these are high-level company decisions. That's the conceptual design. Translating them into tables, now you got to have some technical knowledge. And so at that point, the DBA comes in. So this is a handoff from DA to DBA. External, again, is a combination of DA and DBA. You know, the people in payroll, how much information do we want them to see for the employee table? Probably not all of it. The people in parking, we don't want them to see the salaries. Why create envy in the cafeteria, you know? So, all right. So the decision about, you know, what external views to have, a lot of that is initially done by the DA, and then the DBA creates the views. All right, which are database objects. Well, fine. So we got through that. Let's see, what other lists do we have? That's not bad. All right. Later on, we'll talk about the stages of database development, and that sort of parallels the development of any big software project. So you have the usual stuff, you know, step one, design requirements, you know, and so on until you get down to maintenance. And we'll talk about database maintenance when we, you know more about what we're doing. So we'll get to that, talk about that later. But we don't need to get into that now. All right. So what I'm going to start talking about next is ER and relational algebra and relational calculus, because those are all theory topics. And we'll do that till we can't stand it anymore. And I find this stuff a little boring. We might take an early break. In general, I'm not fond of lists. Even when they're fairly short, I don't like lists. All right. Well, let's do relational algebra. Okay. Early database strategies. Divided into three categories. Typically, people talked about hierarchical databases, linked databases, and relational. Okay? And I remember, you know, back in the 70s having a yellow and purple book that was divided into three parts, and, you know, they talked equally about these, and there were implementations of all three strategies. I don't remember anything about that book now except the colors. All right. These two died. And this guy became the champion. All right? So that's all that's left. Everybody now does RDBMSs. or extensions of RDBMS. Which is, of course, Relational Database Management System. In talking about this, if we have a table like sales, I would usually, for short, describe it like this. We have grade, roll, low sale, high sale. I did this one because it's the easiest one for me to remember. All right. Right now, you're better at this than I am because you just typed it. All right. What is this? Well, you know, this was a string, and the last two were numbers. Actually, one of these was, let's pretend they were both strings, and the grade is not a number 1, 2, 3, but all right. So let's say it's basically of the following form. You've got a string, and then you've got a string, and then you've got a number, and then you've got a number. Okay? So I have written this as a cross product, aka Cartesian product, to use that fancier word, which is less clear. All right? It's a cross product of 4 types. And a row in the Sales Bubba table is a 4-tuple. Okay? And there's nothing wrong with calling them tuples. So Sales Bubba is a set of 4 tuples. All right. So what's a 4-tuple? Well, it's something of this form, you know, because this is what a 4-tuple looks like, right? When you take discrete math. That's what a relation looks like. Hence the term relational database management system. That's a relation in discrete math terms. If it's a function, then it's got some additional properties. But you know, at the simplest level, a database table can be thought of as a mathematical relation, and it looks very much like that. Okay, so this is a relation. The alternate word for relation is predicate. So you could have called it PDBMS for Predicate Database Management System, but people understand relation better. It's easier to spell. So, you know, the word relation won out. Now, how did it win out? Okay, there is the grandfather of relational databases. So you get to learn a name, E.F. Codd. I don't know what the E.F. stands for. Okay. Okay. Maybe he's British. I was thinking about that last night because of a television show I was watching. They were talking about H.G. Wells, okay, known by his initials. And more recently, you've got J.K. Rowling. Some of you know that name. All right, E.F. Codd. Who cares what the initials stand for? Anyway, he's the grandfather of relational databases, and what he did was develop the theory. And the claim is that relational databases won over the other 2 schemes because it was based on a very sound mathematical theory of relations. All right, so we're going to get into that now. Based on good math, due to this guy. All right. So now we only learn RDBMSs, which is good. I had to force myself through the purple yellow book. Okay. So that brings us to ER, which is going to force me to look up some stuff in my notes. sooner or later we had to get in. So we'll get rid of some of this and start talking about ER for a while. ER stands for entity, gotta spell it right, entity relationship model. I'll try to get a new marker pen during our first break. Entity relationship model. So this is a design model. It's, like I said, it probably is more management than technical. Okay, but let's, before we do that, do relational algebra. I'm going to write them down because I just talked about them before. This is similar to UML, the Unified Modeling Language. The Unified Modeling Language is for OOP projects, and ER is for databases. All right? But they have a fair amount in common. And I've seen versions of, yeah, you put it on the table here, and then I'll write late on it, and, 2-inch high letters, and get it to the grader later. Okay. And the third thing that I said I was going to talk about is relational calculus. This is actually based on predicate logic. And we're going to do this in the following order, 1, 2, and 3. And I don't know if I'll do them all tonight or not. But let's start with relational algebra. The odds that you ever took a course in computability are very small, but there's an analogy there. Relational algebra is an inductive definition, not circular. So what the relational algebra theory does, and it is primarily due to Cod, there are a list of 9 primitive operations, okay? And the primitive operations can be thought of as the basic things that a human being would like to do to a database. All right? And then you're allowed composition. So this is very much like the definition of partial recursive function if you're, ever took computability, but you probably didn't. So what I need to do is to make a list of, according to my memory, 9 primitive operations. Okay? So, relational algebra. And we'll start the list. Maybe on a new board. One of these. And to get them in the same order, I'll try to flip through and find my notes on this. It'll also help me make sure I remember all 9. Relational algebra. Basic operations. All right, I said I didn't like lists. We're going to have another one. I think the first one is renamed, but I'll try to make sure. Yeah, sure. Yeah, sure. It's probably pretty deep down under here. We're getting there. We're very close. Oh, I have some more, I have another list of buzzwords I could do. And again, you probably ought to know if you get that. All right, where's the simple short list? There, I found the simple short list. After a lot of other related stuff. Okay. What's the name notation? Hopefully the names will be fairly short because they didn't leave that much room. I was right, the first one is called rename. P sub S of R is the notation. The idea is simply to give a new name to a table. Okay, that was considered basic. You know, for whatever strategic reason, sometimes you want to change the name of a table. Okay, fine. R is the old name. This is the new name. Okay, so the function is applied to the old name to create a new name. This is the notation that's in Sundaraman. So if you find a Sundaraman, you will find that he uses the same notation that I'm using on the board. Okay, that's obviously an unexciting operation. We go on. 2, union. Notation. Union sign. Yay! All right, so it stays easy for a while. 3, intersection. And to finish it off, the set theoretic ones, the last one is difference, and the usual notation is a minus sign. All right? You know, examples would be, you know, you've got one table for, I don't know, hourly employees, and another table for monthly employees, and you decide to make a single table out of the two. Assuming that they're fairly similar in design, then you should be able to do a union. All right, so these are basic set theory operations with the usual meanings. Okay, 5, product. Notation is an X. Okay. Now, I can't demonstrate things to you because I don't have Oracle access yet either. Till that employee gets back from her conference, we're probably not going to get there. Okay, so my suggestion, my basic suggestion is download Oracle 11G Express Edition on some machine that you have. And that way you'll be able to play. I make my spatial database class do that in the spring, the 615 class. I leave them no choice. In this class, it's always been optional. It's less optional this summer, maybe. Yes, sir.
Like for Mac, there's no like Oracle for Mac, so.
Yeah, no, that hurts. We're hoping that your mother or your brother or some friend has a non-Mac.
If for some reason I can't find someone, can we still email you and run it through you?
Yes.
Okay.
Yeah. For a small service charge, yeah, you can. The old system. Okay. So the idea of product would be something like this. This is how you implement it in SQL. Okay, so I'm going to sneak into some SQL. All right, as we go through this, very few people know what that does. You're about to. There's a semicolon at the end that I won't always put on the board. All right. If you do a comma-separated list of table names, you get a cross product, whatever that means. Okay, here's what it means. You take the fields in EMP, of which there are 8, and the fields in info, of which there are 6. That sound right? 6 fields in info. And you add the number, and you get 14 fields. Okay? And then what you do is you take a legitimate cross product. You pair each row in M with all of the 15 rows in info. Then you take the second row and pair that with all the 15 rows in info. And what you get is a new row with 14 columns. There's a way to give a name to it that I'm not going to get into. All right, but you can actually create a table by doing this. And you can create a cross product. Now, what's the disadvantage of that? And this is an important point. The disadvantage of that is both tables have a column called EMPNO. And yes, you will end up with 2 of them. So it's a true cross product. And so it's not used very often. And that's why very few people know what this does. Now we're going to have a very quick numeric quiz to see if you understood what I was saying. And if not, we'll blame it on me. That's how I handle graduate advising. If I need a favor from the graduate division, I say, it wasn't the student's fault, it was mine. Surprisingly effective. Okay. How many rows will be displayed if I run that code?
2.
How many rows will I see if I run that code?
2.
You haven't heard the number yet.
So it's 6 or 20.
It's 48.
32.
Haven't heard the number yet. You got a cross product of a table with 15 rows with a table with 15 rows. 225. Think product. Okay? And it's like I said, you know, you will get 1 row corresponding to each row in the first table paired with every possible row in the second table. That's 15 times 15. If you actually do this on an Oracle, you will find that you get 225 rows. You will also find that the table is stupid and not very useful. But there it is. And the reason this was thrown in is probably because of the idea a table's a relation. What's the most natural thing you do with a relation? Yeah, you take cross products. Okay? That's how you got a relation in the first place. So it makes very good sense from that point of view. Now I have to try to find my list again. Here it is. Okay. So this is not, to me, an important one, but you actually know how to program it now. I'm going to tell you how to program these others too. Yay! So we're going to do a lot of SQL. It always sounds like all theory. 6. project. The notation is pi sub a of r. And again, it's supposed to look like a function, okay? Now, you know, Greek letter pi starts with a P, supposed to suggest project. That's all that's going on there. But that's the notation that's used. Every 1200 database book teaches this stuff. It's actually in the first 5 pages of Sugaran with the notation that I'm giving you. This doesn't make any sense until I give you an example. So I'll give you an example. Pi sub ename pause sale of imp bubba 02. What would that be? That would display, if you could run it, those 3 columns of the employee table. You get 15 rows and 3 columns. Okay? So that's like select. Okay? And so sometimes I call this project slash select. But project is better because select can be used to take a subset of either columns or rows. Yeah. So select is vague, project is not. So this is like a projection from like XYZ coordinates. If you project on the x-axis, you only see the x column, right? So it's like the project that you learned in calculus. Yes, sir?
So that's the unique rows?
It's, you know, it's theory, but yeah, it would be exhausted. If you had 15 rows in this table, you will get 15 rows in the projection.
But if,
You'll get all the rows, but only some of the columns. It's a way to restrict the number of columns.
but if the ename pose and cell for multiple columns are the same, you would only get one representation of them.
Well, it's possible to get duplicate rows, although it's considered, you know, bad form. It's not possible to have duplicate columns. Yeah. So column names have to be distinct. All right. So this is project. So, and often what I do on exams is I ask people to translate between SQL and relational algebra. So you know what this looks like in SQL. It's select ename, comma, pause, comma, sale from imp bubba 02. See, the translation is very easy between the two. All right, so it's a kind of a trivial translation. All right, and the word project is chosen from relational terminology. That's what a projection is. All right, now we go on to number 7. Seven is restrict, and again I said, select is vague because we can restrict either columns or rows. We restrict columns by a comma separated list. We restrict rows by where. All right? The reason I'm putting select on parentheses here is because of the notation. If they were being good, then for restrict they would use the Greek letter rho. But that isn't what they do. They use sigma. Sigma expression R. All right, so I'll give you an example of this, but you're going to translate this by using a where clause. Okay. So an example of this would be something like sigma department number less than 40 Imp Bubba 02. Okay? So this is basically Boolean. I'm trying to say which rows I want in intuitive terms. So here I'm restricting the number of rows, and now I want rows for which the department number is less than 40 in terms that should now be familiar to you. This would display, if we were to display it. Software wouldn't do it anymore because this is software, but it would display the infield, the outfield, and the pitchers. It wouldn't do staff or pitchers, right? Okay. These are the important ones that we already know about. Now, here's what we don't know about, but it's also important. So the important ones really turn out to be 6, 7, and 8. Anyway, we're up to 8. These boards are not very big. So 8 is called join, and in parentheses I will write natural. It's a natural join, and the symbol is a bow tie. Hey, what can I tell you? Everybody uses the bow tie. Okay? Now, what this is a subset of the product. So it's fairly hard to describe. I'm going to take a shot at it. This does turn out to be a natural join in the sense that it's the join that you commonly want as an application program. So we'll spend a bunch of time on this tonight. Okay. So A, bow tie B. Definition. If A has columns or attributes or fields, I don't care what you call them, A1, AM, C1, CK, and B has columns. B1, BN, C1, CK. Then I can describe the columns in the natural join. Then, a natural join B has columns. Now remember that the columns don't have any magical ordering. A table is a set of unordered set of columns. So it doesn't matter what order I write down. A1 through AM. I'll stick with C1 to CK. B1 to BN. Okay? Those are the columns. So what's happening here is the common columns only show up once in the natural join, unlike the cross product. So if I take the natural join of the employee table and the info table, all right, I won't have 14 columns, I'll have 13 columns because EMPNO will only show up once. All right? So that's the big distinction. Common columns only show up once. So we can write that down as an illustration. So I'll be sloppy. Imp natural join info has 13 columns. And we'll write the other one now just to nail it down. Imp cross info has 14. Okay, so that deals us with number of columns. Once I get done with the list, I'm gonna cheat and go fast on number 9. And we can talk about that more when I come back. We'll talk about all these more when I come back. When we all come back, you're not gonna stay here. Okay. The question is, what do the rows look like? Okay. So, a row has the form A1 through AN, C1 through CK, B1 through VM. I'm going to write it as a tuple, where the A's and B's are from rows in A comma B with matching C's. I don't know of any nice way to write this. But I can illustrate it with our friends Imp and Info, now that you guys are all on board. All right? So if I take the natural join of Imp with Info, I'm going to take a row with, say, Lasorda with ImpNo 735, and I'm going to pair that with a row in Info, namely Tommy, which also has ImpNo equal to 735. All right? So to get a row in the natural join, you take a row from each table where the columns in common match, and then you take the cross product of the rows, but you only include the common columns once. All right? So this is how we would combine the information in Imp and Info. You would say natural join in relational algebra, and now you would get Tommy Lasorda, Willie the Say Hey Kid Mays, Teddy Ball Game Williams, and you would get all the information about each player, which might be more columns than you wanted most of the time, but once in a while you take a join. Joins are potentially expensive. They're not quite as bad as cross product, but it takes a lot of time in a database to join two gigantic tables. So these are costly operations to do, but often you can't avoid it. Yes, sir?
Yeah, in respect to the performance, does the type of field matter? You have,
What was that?
would the type of field matter that you're going on for performance?
Right. The columns in common really should be identical as to name and type. That's an important point that I'll get into when we come back. There's a concept called union compatibility. And so the common columns should be union compatible, i.e., in a strict definition, identical names and identical types. Oracle will do it if the types are close, but there's a limit. Okay. All right, let me give you a concrete example of how this is done in SQL, because you don't know. And I want another board over here, because I don't want to put it on any of the boards we've got. How about here? There are two ways to do this, and I'm going to give you both of the ways. Okay? Select star from imp
Form.
Bubba 02, and then you use the actual words natural join, get over there, info, Bubba 02, semicolon. So, from the relational algebra theory, SQL borrowed the words natural join because you can't find a bow tie on a keyboard. If you could, they'd use it. Okay. All right. So this is one way to do a natural join, and natural joins are the most common common forms of join. There are other forms of join that are abstractly possible to do. Sometimes people extend the theory to allow what are called conditional joins. I'm not going to belabor you with that. We'll stick with natural. All right, here's the other way to do a natural join, and I'm going to introduce a new term, equijoin, and after I get done with this one, we take a break. All right. The idea of an equijoin is basically, it's a join in which you use an equal sign. So that makes it pretty simple to remember. All right, so we're going to do the syntax another way. This time we use a comma-separated list of the tables and a where clause. And the where clause, if you had multiple columns in common, would have a lot of ands in it. But in this case, we only have one column in common, and that's the column EMPNO, right? So, now, in order to do this, we can do it this way. And I'm going to do it this way, which is a little bit painful. You can use dot notation. Imp Bubba 02 imp no equals info Bubba 02 imp no. And now it's an equijoin because of the equality sign. Okay? Now, I actually do it most of the time this way, even though it's more typing. Because it's flexible. Some other time I can use something besides equals, or I can add additional clauses. Whereas natural join is kind of, like a one-shot. Okay? And I can extend the where clause and make it a lot more complicated if I feel like it. All right, so these are the two ways to do a natural join in SQL. Now, final little trick, and I'm going to abuse the privilege I have of having an eraser and a pen. It's like a phone and a pen. Okay. I'm going to write this a little smaller. And this is important stuff. There's a space in here. I told you I was going to try to write it smaller. How's that? Okay? Imp Bubba 02 space E, info Bubba 02 space I. The E and the I have names. They are called table aliases. So I'll throw that up here. These are on-the-fly aliases, and they're designed to be short, so you don't have to type so much. Extremely common. And then down here, I write E.empno equals I.empno, and that's all I have to type. I use the aliases. Yay! All right. It's possible to do column aliases, and we'll talk about those after the break, probably. I want to finish the list. Where's the list? Here it is. 9. Divide. Dot/dot. The usual integer division symbol. This is extremely unimportant. That's why I saved it for last, and I'm not going to talk about it now. You never really need it. Okay? It was thrown in there by COD because it gives you a potential easy way to do restrictions of the form for every. But it's almost never used. You don't need it, and you never need it. This one is redundant. I can define this one in terms of the previous 8, and the algebra for doing that is in Sundaraman. I'm not going to even put it on the board. It's not important to me. Divide is not important to me. Okay? All right, we're on break.